Welcome to the part 12 of our data structure lecture series, and in this part 12 we are going to discuss about pointers and multidimensional arrays. In past tutorial we have discussed pointers with single dimensional arrays. I am going to recall the single dimensional array here. If I am talking in terms of single dimensional array, so suppose I am considering this as a single dimensional array. This is an A single dimensional array. This is A whose name is A, and these are indexes of this single dimensional array: A of 0, A of 1, A of 2, A of 3 and 4. This is the first index 2, and suppose I am considering its address as 200. Say its memory address is 200, but if I am going to give the memory addresses of this 4, 6, 8 and 10, what will be the next memory address? Because this is integer type data, 2, 4, 6, 8 and 10. These are all integer types of data. There will be the change of 4 bytes. Normally there will be the change of 4 bytes. If this is 200, the address of this 4 will be 204. Address of this 6 will be 208. Address of this 8 will be 212, and address of this 10 will be 216. There are 4 bytes change in each address at each address location. If I will write here int asterisk p is equal to a, basically what is a? A is the name of the array, and if I am talking in terms of name of an array, if I will print this, print p, what will it print? As we know, if I am using the name of the array, it will return the address of the first element of an array, as I have discussed it in previous tutorials as well. So what is the first address of an array? This is 200 memory address. Okay. Now if I will write print asterisk p, what is it going to return? It is going to return the dereference. It is going to dereference this 200, and when it dereferences this 200, its value is 2. Basically it is pointer to integer. Okay, if there is double pointer, that means pointer to pointer, but it is pointer to this address. This means pointer to, what is this address? This address is of integer type, you can see here. So it means pointer to integer. So whatever is located at this 200, it will dereference it and it will print that. So it will print 2. Okay, now if I will write print p plus 2, what is it going to write? But I will dereference it. I will write here star. It is going to write p. P is the address of the first element, that is 200. So it will give 200 plus 2. What does this 2 mean? 2 doesn't mean 200 plus 2, that is 202. No. 200 means you have to add 2 more elements after this. So this is first element and this is second element. Okay. That means I have to change 2 addresses. First address is 4 bytes change and second address is 8 bytes change. 4 bytes plus 4 bytes is 8 bytes change. So I have to make the change of 8 bytes here. So I will add 8. 4 plus 4, that will give me 208. So whatever is written at 208, this is 6 written here. So it will give me the answer of 6. Now I am going to talk about multidimensional arrays. And for multidimensional arrays, we know that if there is a 2-dimensional array, that is also a multidimensional array. I'm going to illustrate this example with the help of 2-dimensional array. So I will write here, I will declare a 2-dimensional array here, int b of 2 and 3. This is an array b that I have made, and there are 2 elements in it. First dimension represents main array, and that is of b0 and b1 element. Further, each element contains three more elements. That means each element contains one more array of 3 elements. So this is 3. This is actually, if I have 3 written here, that means this b0 contains one more array which has 3 elements, and this b1 contains one more element that has 3 elements. Okay. If I am talking of b0 and b1, when I am talking of b0, its address is 400, and b1 it has an address of 412. Why there is a gap of 12 bytes? Can you imagine why? This is because this b0 contains 1, this is 1, this is 2, and this is 3 integer type data, and each integer type data contains 4 bytes. First 2 is, this 2 is at same location where this 400 starts. this 2 also starts at 400, so its address is 400. And this 3 has an address of, make a change of 4 bytes. 400 plus 4 is equal to 404, then 408, then 412. Okay, this has also 412 because this is the first array, this is the first element of the array contained by b1. So this 412 and this 412 starts from the same location. This is 416 and this is 420. This is 4 bytes plus 4 bytes plus 4 bytes. It is 12 bytes. So there is a 12 bytes of change from here to this location. Coming back to the point, as we know, name of array returns the address of the first element of an array. If I am writing here B, it will return me the first address of an array. But this time the case is different. In case of single dimensional array, it was easier for me. But in this case, suppose I will write here int pointer. I am declaring a pointer variable p is equal to b. But this is a wrong way. Why this is a wrong way? Because this is a b and this is the name of the array, and it will return the first element of an array. That is first address of the first element of an array, and the first element is b0. When I am talking of b, it means first b0. But b0 does not contain any number. What will it return to this pointer p? What will it return to this asterisk p? Because this further contains array. This further contains this 400 address, this 404 address, this 408 address. Okay. This b0 does not contain any integer value. This contains further one more array. So I have never mentioned that in this. So the correct way to write this is int asterisk p, and this was returning me the this was returning me the what is contained at b0. But b0 contains the array of 3 elements. So I will write here second dimension 3 is equal to b. This is the correct way. Why this is the correct way? Now I am assigning the name of the array here. Name of the array, and that is b. That will return me the address 400. But that 400 contains further 3 elements that I am mentioning here. Okay, this contains further 3 elements, 2, 3 and 6 at 3 address locations. And the first address location, address of 2, will be the same as the address of 400 because this is the starting point. Okay, this is the starting point inside this array, inside this main array. Okay, now we will come to the point again. Now the correct way to write is this. Okay, now if I am going to write print b, what will it return? Print b, it will return of course the address of the first element of b. This is 400 and 400 will get printed. For this I can also write, if I am going to write this 400, so I can also write print and of b of 0. This is b of 0 and the end of this b of 0 is this address 400. It will also return this 400 and will print this 400. If I will write print asterisk b, same thing can be written like this, or b of 0, same thing can be written like this, or and of b of 0 and 0. Okay, this b is going to dereference, b is the address of the first element of an array, and that is going to dereference. But we know address of this array is this will return this 400 because this is the address. When I am mentioning b, this means this 400 as is the first element of an array. And if I am dereferencing this 400, what does this 400 contain? This contains further one more array. So we have to mention the address of further one more array, and first element is the address that is going to represent the whole array. Okay, so I have to write the address of the first element. So it will give me this 400, not this 400. It will give me this internal 400. So I am going to write 400. Similarly, b0 and 0. This is b0 and it is 0 element. Internal 0 element is this, where 2 is located, and the address of that is 400. Address, why? Because I am talking of address because here and is written. So this element represents this 2, but this AND represents the address of this 2, that is 400. So this will return me this 400. If I'm going to write print b plus 1 or AND of b of 1, what is going to return? B plus 1. B is the address of the first element of an array, that is 400. I am talking of this 400 plus 1. I am talking of this 400, not of this 400. Not this. This time I am talking of external 400 and I am incrementing that by 1. Incrementing that means I have to reach here. And this will give me 412. So answer will be 412. So this will also give us 412. You can check it. B of 1, this is B of 1 and its address is 412, and we are writing AND before that. This is AND. So AND means this address 412, and that will get printed. B of 1 basically represents these elements, as this is not containing a single integer. It is containing one more array of 3 elements, and I am going to dereference. I am going to write AND before this B of 1. AND means I have to write address of B of 1. Address of B of 1 is 412, and that 412 will get printed here. If I will write print asterisk B plus 1, what does this mean? This also can be written as B of 1, or it can be also written as AND of B of 1 and 0. So what will be the answer? B represents 400, this 400. And if I am incrementing this 400 by 1, that means I have to reach here. This is an external 400. This is not this 400. I have to increment this externally. So when I am writing this B, so it will reach to 412. But it is going to dereference this. External 412 is going to dereference. When I am going to dereference this, what will it return? It is going to enter inside. Dereferencing means entering inside. So when I am entering inside, what it finds is there? It finds this 4, 5, and 8. So it finds the address of the first element of an array, 412. Now this 412 will be printed, not external 412, internal 412 will be printed. So answer will be 412. Same thing will happen by this. When I am going to write B of 1, so I am going to write B of 1. B of 1 represents, when I am going to print this B of 1, it is going to print what is contained inside this. But inside it contains one more array, and the address of first element of that array is 412, and that 412 will be printed. Similarly, B of 1 and 0. What is the B of 1 and 0 element? B of 1 is this, and B of 1 then 0. I have to reach B of 1, and then I have to reach the 0th element, that is 4. But I am writing AND before this. AND means address of. So address of this 4 is this 412. That is answer. Now if I am going to write print asterisk of B plus 1 plus 2, what is it going to return? Or we can also write B of 1 and 2 and it is address AND of. Okay, this is going to write what this is going to print and what this is going to print. This actually is same. This and this will print the same thing. I will show you how. This is B. B means address of the first element of this. This is 400. 400. I am talking of this external 400 plus 1. Plus 1 means I have to reach up to this 412. So here it will be 412. Then 412 should be dereferenced first. 412 is dereferenced first. So I have to reach here and dereference it. When I am going to dereference it, it will reach here. It will reach the internal array, and the internal array has the starting address of 412, and starting address represents whole array initially. So it will give me 412. 412. And I am incrementing 412 by 2 plus 2. Now, if I am talking of 412, which 412 is this? It is not this external 412. It is this internal 412. Internal 412, I am incrementing this by 2. So I have to move on to the two addresses after it. This is the first address 416 and this is the second address 420. So this will give me 420. So 420 will be the answer. Okay, here answer will be 420. Now same thing will be achieved with the help of this b of 1 and 2. B of 1 is this, and I have to reach to the second. This is 0, this is 1, and this is 2. So this will give me 8, but I am writing and before it. 8 is going, this 8 has an address 420. It will give me the address of this 8. This means and of 8. It means 420. If I will write print asterisk asterisk b plus 1, this means I have to reach this b. I have to write this b. B is the address of the first element of an main array, and that is 400. And I have to increment. I have to first dereference it. Dereferencing this 400 will enter here. It will give me the address of the internal array, and the address of the first element of the internal array represents the whole array initially. So it will give me this 400, internal 400. So internal 400, I have to increment it by 1. But I don't have to increment this 400. I have to increment this 400 by 1. This 400 will be incremented, it will become 404. It will become 404 because there is a gap of 4 bytes in each element. Then 404 is dereferenced further. It will give me the answer of this 3 because this 404 is dereferenced. It will give me answer 3. Okay. This was the concept of how we use pointers in multidimensional arrays. Thank you for watching and don't forget to subscribe Indus Technologies.